when the degree of the numerator is higher than the degree of the denominator, then we will have an asymptote that's not horizontal, and when it's greater by 1, we actually get a diagonal line, which is called a slant asymptote or an oblique asymptote. Let's find the asymptotes here. First off, and easily, we see that x equals -3 makes the denominator equal to 0, and that means we will have a vertical asymptote there. Since this function is top-heavy with a higher degree in the numerator, we're going to do some long division. -2x squared minus 3x plus 7 will be inside, and x plus 3 will be outside. We're going to divide here. X goes into -2x squared, -2x times. Multiply by the whole factor on the left here. We're going to get -2x squared minus 6x. Subtract and add the opposite, and that will give us a 3x plus 7, and that tells us we will have a 3 up top plus 3, 3x plus 9. We really don't care about the remainder that we're about to get here, -2. All we're looking at is at this without the remainder, and that tells us y equals -2x plus 3 is the slant or oblique, if you want to use that word, asymptote. Now let's do a graph here. We're being asked to transform this 1 over x squared to this next graph, which is 1 over x minus 1 squared plus 2. 1 over x squared is an interesting graph. Okay, first off, let's start substituting some values in. When we substitute 0 in, we get an undefined function, so the original function does not go through this graph. If we substitute 1 in, 1 squared is 1, 1 over 1 is 1, and we get this right here. 2 gives us 1/4, a half gives us 4, and we get this function right here in red. And the left side is going to end up being positive also, because a negative number when squared makes positive. And we have matching graphs on both sides here. I didn't do a very good job of that, did I? It turns out that whenever the denominator, that vertical asymptote at x equals 0, has an even multiplicity, then both curves are going to approach the same infinity. Normally these curves repel each other and are in opposite corners, but it's that even multiplicity downstairs that draws them next to each other. Now let's look at how this is going to be transformed. That x minus 1 down below is going to control left versus right, and it's actually going to be right 1. And that plus 2 at the end is going to refer to up 2. So our vertical asymptote is going to be right 1. It's actually going to be right here instead. And it's going to be up 2, so where we used to have a point at 1, 1, it'll now be at 2, 3 instead. And we're going to have another matching point on this side. Our horizontal asymptote, up 2, is now going to be at the y equals 2 location. And so we're going to have this curve, which I'm just going to try and draw in blue, as our transformed graph.